continue looking at our equation work for the rest of the day. So we've got to take a look at this one. So we have one. So these are our warm-ups for these. We only have 3 here. So go ahead and start working on these 3 on this page. Pause the video and see what you come up with. All right, so you guys work this one out. The first thing you figured out, you had to divide both sides by 5. So x is equal to 7. Here you multiply both sides by 4. So n was equal to 28. And finally, you did this package of juice. You said, okay, so let B equal bottle price of bottle. Sorry, my poor sideways handwriting. So 8 times B equals 12. You went ahead and, okay, divide both sides by 8. So you found that 12 divides by 8. So you divide 12, that gives you 1, and then you get half. So you get B equals $1.50, not $1.15, $1.50. All right. Let's dig into solving equations with rational coefficients. So remember, we talked about rational numbers. Rational numbers can pretty much almost be any number, but really I think when we say rational, we're figuring that we're thinking in terms of the idea of fractions and decimals. Okay? So let's dig into how this works. So our goal is that you can solve an equation when you see a fraction times a variable or a decimal times a variable and be able to work it through. So let's take a look and think about how this works. So if I've got this same kind of style problem, so now I've got a rational equation in decimal first, and then we'll work into fractions in a moment. So if I have this rational equation, I say, okay, I've got 16 is equal to 25/100 n. So it's multiplication, so I know, because that's what coefficients are, is any number right in front of the variable. I'm going to use that division property of equality. So I'm going to divide both sides by 0.25, and then I'm going to have to do the math on this, right? I'm going to have to go 16 divided by 0.25, which we know doesn't work. We got to move our decimal point 2 places. So again, we got to go do some math. Now I know my 25 times table is pretty quick, so I'm not really super worried about having to estimate or anything. I know 25 goes into 166 times. So that's 150. Subtract, I get 1 and bring down my 100, so I know 25 goes into it 4 times. So I've got my answer. I've got n is equal to 64. Okay? And if I tried that out, I do end up getting the right answer. Now I do the same thing here. I divide. So now it's your turn to try the same thing on this problem. Pause the video, see what you come up with. All right, so this time we're going to divide by 5/10. A little easier to kind of work with. So we think about, okay, if we've got this, so now I know I'm going to cancel that out. So let's bring it over here and go 10 divided by 0.5, and I got to move my decimal point, right? So I've got to add an extra 0 on this side. So 5 goes into 10 twice, so that's 10. But what do I do with that 0 I bring down? I know it goes that 20 is equal to x. And that makes sense. Half of 20 does equal 10. All right, so it's some word problems. Let's kind of take it through, and where this is more likely going to come into play than like those just standard equations we had a moment ago. It's really going to come into play way more often when it comes to real life, because in real life we have lots of decimals, especially when it comes to money. So Jay as coach agreed to buy ice cream for all team members. That's nice of him. Each ice cream cones cost $2.40 each. Write and solve an equation to find out how many cones the coach can buy for $30. So again, so just like we were talking about, so this is an equation. So I'm looking to see, I've got this word each, so I know it's a multiplication equation. And I know this is my total. So let's get my let statements. Let C equal cones. C equal cones. So we know it's $2.40. Now, I know it's money, but I can drop that 0 while I'm doing the work here as long as I know it's the next piece. Equals 30. I can add the extra 0 if I want to, but when it comes down to working on division, I don't really need to drop that 0. I don't need to have that 0. So I'm going to divide by 2 4/10. So I come over here and do 30 divided by 2.4, slide my decimal, add that extra 0. 24 goes into 30. Well, that's just 1, so I can get that one. So I go 24 times 1. I don't know what my mind was going through. 6 left over, drop my 0. 24 goes into 60 twice. So that's 48. I end up getting 12. I can put some zeros down. 24 goes into 120. Well, I know 2 goes into 12 6 times, but that's a little bigger, so let's go with 5. 5 times 24 happens to be 120. I get 0. So the question is, how many cones can he buy? He can't buy half a cone. So we're gonna say let C, or sorry, not let, just C is equal to 12.5, but the correct answer is 12 cones. He can't buy half a cone. Okay? So hopefully that team is smaller than 12. You guys give this one a try with Jamie trying to cut pieces of siding that are 3 feet long, 3.5 feet long. All right, so let's give this one a try. Let's think our way through it. So write and solve an equation to find out the total number of pieces. So let's say, let's go with X equals pieces of siding. How many pieces of siding can Jamie cut? So now I've got this equation, so I know that it's 3, each piece is 3.5. So when I think the word each, anytime I hear each, I know it's multiplication. 3 and 5/10 times X is equal to 21, because that's how big the piece is. We're going to do our division, 3.5. We're going to divide it right here, 3 and 5/10. So we're going to come over here and do our division. Okay, 21 divided by 3 and 5/10. Move our decimal point. So it's really this. So 3 goes into 10. That's 7 times, but since it's a little bigger, we're going to say 6. 6 times 5 is 0. Carry the 3. 6 times 3 is 18 plus 3 is 21. So he can get a total of X. He has 6 pieces of siding. All right. Let's take a look. All right, now we have rational coefficients in terms of fractions. Now that's exactly the same as decimals. Since decimals and fractions really are exactly the same, they're just different ways to write the same idea. But we're going to solve it a little differently this time, okay? Because I really can't do division of fractions, right? We know that we've got to use our keep, change, flip. So when I multiply by, so if I come over here and I'm saying I'm dividing by 3/4, I'm not really dividing by 3/4. I know when I divide by 3/4, I'm really multiplying by its reciprocal. So when I do a problem like this, I'm going to come over here and go, okay, well, if I say I divide by 3/4, I'm really multiplying by 4/3. That allows me to get those cancels, to get X over here. And then I can do my cross reducing. I can come over here and go, okay, that's 1, that's 5, this is 1, this ends up being 4. So 1 times 4 and 4, X is equal to 4/5. And if you check it in, 3/4 times 4 times, 4/5, you end up getting 12 over 20, which is exactly what we started with. Okay, go ahead and give this next one a try. All right, so let's multiply both sides by 3/2. Again, I can cross reduce down to 1 and 5. They won't always cross reduce like this, but this one makes it easy. 2/5. So I go, okay, X is equal to 2/5. And again, if we check that, 2 times 2, did I do that wrong? Oh, that should be 3. I didn't catch my mistake till right then. 3/5. So 3 times 2, that's why we check our problems. I caught myself making a mistake because I cross-reduced incorrectly. All right, so we get the idea of 3/5, not 2/5. All right, now we have the same thing. Now we have Valerie here. Valerie needs 2/3 of a yard. I'm going to move that over. 2/3 of a yard of fabric to make each hat for the school play. Ooh, I need a space in there. To make each hat for the play. Write and solve an equation to find out how many hats it will take if she has 6 yards of fabric. So again, we're going to look at this. Okay, first things first, let's find what is she trying to find out. How many hats? So let's say let H equal hats. We know that each hat, so here's each, that's multiplication. That's 2/3 each hat times hat, and H is hat. So 2/3 times 2/3 H is equal, and we know that 2/3 times hat equals 6 yards. So we're going to multiply by my reciprocal. Now I've got a reciprocal 3. There we go. Let's make that look a little neater. So we have 3 over 2. Now again, we can still cross reduce. We got a whole number and a mixed number, or a whole number, sorry, and a fraction. But we can still cross reduce. This times turns to 1. This becomes 3. 3 times 3 is 1. Or sorry, 3 times 3 is 9. Not 3 times 3 is 1. 3 times 3 is 9. And she can make 9 total hats for the school play. All right, it is your turn to figure out how Samantha can do her stuff. So if Samantha has 4/5 of the question on her science quiz correctly, if she answered 8 questions correctly, write and solve an equation to determine how many questions were on the quiz total. So first things first is do our let statements. Let Q equal quiz questions, or Q equal questions. You could write either way. So 4/5 times Q is equal to 8. So we multiply by a reciprocal of 5/4. Cross reduce down to 2 over 1. So there are 10 total quiz questions on the quiz Samantha took. All right, so we've got a really good start on these. It's your turn to go ahead and attempt and work on your homework. If you have questions, again, please reach out to me. Come see me during help session. I'd be happy to help.